Welcome to my channel. Today I'm going to explain how JavaScript works in the Chrome. So it have many concepts like memory heap, call stack, event loop. I will be explaining this in same video. So JavaScript has an engine that is we call as Google V8 engine. The V8 engine is used inside Chrome and Node.js. So we have the engine consists of two main components. This is memory heap and call stack. Memory heap is used to allocate the memory. So memory allocation happens in memory heap, and call stack where we execute the code. The runtime there are APIs in the browser like set timeout. These APIs are not provided by the engine. So actually from where it's coming from. So we have engine, but there is actually a lot more. We have those things called as web API, which are provided by browser like DOM, Ajax, and timeout. And then we have event loop and callback queue. So we have memory heap where memory allocation happens, call stack call stack where code get executes, and we have web APIs. What is call stack? Actually, JavaScript is a single-threaded programming language, which means it has a single call stack. Therefore, it can do one thing at a time. The call stack is nothing but a data structure which records basically where in the program we are. So, if we step into a function, we put it on the top of the stack. And if we return from a function, we pop up the top of the stack. That's the stack can do. So it's a LIFO operation. So suppose if we take an example, here is the example. I have created one function multiply xy, returning the multiplication of xy. Then the print square is another function I have taken, and I'm trying to console the s. When I call the print square, so JavaScript is single threaded, so it executes one by one line. So it push the print square to call stack. When it go inside print square, first line is multiply x. Sorry, it should be y. Sorry, it's a xx, so it will get push. So here another function get pushed to call stack. After that, it performs the multiply xxy and it returns. So it get pop off, and then after that console log s get pushed to it. So print square, this get push and pop, and then come to next line, it get pushed to call stack. It returns that and pop up from the call stack, and then it left with print square. And at the last, it also get return. It get pop up from the call stack, and call stack get empty. This way the call stack works. So, and this is exactly how stack traces are being constructed. When an exception is being thrown, it is basically the state of the call stack when the exception happened. So suppose we are creating some function which throw the new error like error, and then we are recalling that function again and again. In this, if this is executed in Chrome, the stack tracks will be produce the error, that is uncuffed error, because it comes under the blowing the stack. This happens when you reach the stack maximum call stack size, and that could happen quite easily. So it if we are calling the function recursively, it throws that error. So most of the developer has already seen that maximum call stack size is exceeded. This error most of the developer, I think, till now have come saw this error. So running code on a single thread can be quite easy since you don't have to deal with a complicated scenario. But running on a single thread is quite limiting as well since JS has a single call stack. What happens when things are slow? So here event loop and concurrency comes. What happens when you have a functions calls in the call stack? That task is huge amount of time in order to proceed. For example, imagine that you want to do some complex image transformation with JavaScript, right? So you may ask that why this is even a problem. The problem is that while the call stack has a function to execute, the browser can't actually do anything. Else it's getting blocked. This means that the browser can't render. It can't run any other code. It just stuck, and that creates a problem if you want a nice fluid UI in your application. So actually once your browser start processing so many tasks in the computer system, it may stop responding for quite long time, and that we call means how we can execute heavy code without blocking the UIs and making the browser unresponsive. The answer of that question is asynchronous callbacks. So we have uh, asynchronous programming where we can achieve that by using callbacks, promises, and async await. So what is asynchronous programming actually? That is a pattern that allows multiple tasks to run concurrently without blocking each other or main thread. So we have callbacks, promises, async, and await. I'm not going to explain those in the same video. I will come up with the next video with each explanation for callback, promises, and async await. But yeah, we have event loop, right? So here if you see, we have event loop and callback queue. So what is event loop in JavaScript? Code is executed in single threaded environment, resulting in one block of code can be executed at a time. This leads to a problem in JavaScript because operation can take a long time to complete, such as network request or file input output, which can cause the problem to block or become unresponsive. To avoid blocking code execution due to long operation, JavaScript provides a mechanism called as event loop, which continuously monitors the call stack and data queue. While the call stack knows about the functions that are currently being executed, the message queue holds a list of messages and their associated callback function. If the call stack is empty, the event loop checks the message queue for any pending messages, retrieve the associate callbacks function and pushes onto call stack where it will be executed. This event loop mechanism allows JavaScript to handle asynchronous events without blocking the program. For example, imagine a program. I have one program for you. Yeah. Imagine a program that wants to perform a network request. The request will be added to the message queue. The request will be added to message queue. The program can continue to execute other code while waiting for the network response. If a response is received, the callback function of the network request is added to the message queue. And event loop while execute it when the call stack is empty. So example, if we have console log starts, then we have set timeout and we have promise and then end. So, what it will give the response. So you may think that starts or inside set and then it should say inside promise end, or some of you may say that starts end inside set timeout and inside promise, but actually it doesn't works like this. So if we check it gives the response starts, then comes to last line, then inside promise, and then inside set timeout. So this might means since the set time out is set to 0, so you might expect it to be executed immediately or immediately after the synchronous calls that log starts and ends. The reason that promise is logged before set timeout is due to the way that JavaScript event loop works. So Java event loop further get distributed to micro and macro tasks. So promises, async, await comes in the micro task, but macro task is like set timeout, set interval. So this way the event loop and whole JavaScript runs in the browser. So thank you so much. If you have any comments, please write down in the comment section. If you have any questions, also please write down the same comment section. If you like the video, please like, share and subscribe. Thank you.